I'll just set everything in. All right. Yeah. So once again, a very good afternoon to all of you. So today we are going to look into the new topic called aldehydes, ketones, and carboxylic acids. Okay. So here, this lesson is also an organic chemistry lesson. Okay, in which it involves the nomenclature, preparation, physical properties, and chemical properties, uses, etc. Okay. So in the last lesson, we have discussed about alcohols, phenols, and ethers. And here about the other three functional group containing compounds. Okay, aldehydes, ketones, and carboxylic acids. So now before moving into the chemistry part of it, let's look into some practical use of these three compounds. Okay. So I hope you all can able to see a picture on your screen. What it is? It is an ice cream, right? Vanilla flavored ice cream. Right? So here, yeah, it is an ice cream, vanilla flavored ice cream. So here if you see, a compound is present. A compound is present here and that compound is called as vanillin. The compound is called as vanillin. Okay. And I will show you one more picture. So what is this? What is this? Yeah, nail polish. Okay. Nail polish remover kind of thing. Okay. So, and this contains a nail polish remover. Yeah. It is acetone. The compound that is present inside this is called as acetone. Okay. And let me show you one more picture. See this. What is this? What is this? This is a perfume. Okay. And the compound that present in this is called as benzaldehyde. This is called as benzaldehyde. Okay. And I'll show you one more picture. What is this? What is this? Vinegar, right? It is given. So this is vinegar. So here the compound present is, yeah, very good. Carboxylic acid, and the name of that carboxylic acid present in this compound is acetic acid. So in all these compounds, if you see the group, the functional group present in all these compounds is the functional group present in all the compounds is in case of the first vanillin, this is aldehyde. Okay. And in case of acetone, if you see, this is a ketone. All right. And in case of the third perfume, if you see, it is an aldehyde. And in case of the last compound, it is COOH, and that is called as carboxylic acid. Okay. So this carbon double bond oxygen, the C double bond O containing compounds are called as carbonyl compounds. C double bond O containing compounds are called as carbonyl compounds, and about that I will talk to you in the introduction part. Okay. And in this lesson, we are going to study about these three compounds only. All right. Is it clear for all of you? So now in this lesson, first we will concentrate on aldehydes and ketones, and we will study about all the informations regarding aldehydes and ketones, and later on we will move into the carboxylic acid part. Okay, like we have done in the previous lesson. First we have discussed about alcohols and phenols, right? And later on we have jumped into ethers. In the same way, we are going to discuss about aldehydes and ketones first, and after completing that entirely, we will move on to carboxylic acid. All right. So now, in today's session, the learning objectives for today's session is the introduction to aldehydes and ketones, preparation of aldehydes and ketones, physical properties of aldehydes and ketones, and at last structure of the carbonyl group. If time permits, I will go for the chemical properties also. Okay. So let us go into the introduction. So what are aldehydes and ketones? Aldehydes and ketones have general formula CnH2nO and contains carbon oxygen double bond group collectively. Okay, and they are called as carbonyl compounds. Okay, so in case of aldehydes, if you see, we will have carbon oxygen double bond with the one side hydrogen and the other side alkyl group attached to the carbon. Okay. But in case of, this is an aldehyde. In case of ketone, both the groups will be alkyl groups. Okay. You know what are alkyl groups, right? So methyl, ethyl, propyl. So all these will come under alkyl group. Clear? Clear for all of you? Clear? So this is the ketone part and this is the aldehyde part. All right. So RCHO is aldehyde and RCOR is called as ketone. Okay. So now let me move into the nomenclature of aldehydes and ketones. So what is meant by nomenclature? Naming a compound. Okay. So we have two different names, right? One is called as common name and the other one is called as IUPAC name. So let me first move into the common name of aldehydes. Let me move into the common name of aldehydes. So let me take one example. The first example is CH3CHO. CH3CHO. The common name for this aldehyde is acetaldehyde. The common name for this aldehyde is acetaldehyde. Okay, clear? So next, coming to one more compound. What is this? Can anyone name this compound? Can anyone give me the name of this compound? Very good. Yeah, exactly correct. This is called as benzaldehyde. Okay. Can anyone try the name for this? Yes, yes. What about this? CHO and OH attached at the ortho position. So I will give the name of this compound. This compound is called as salicylaldehyde. This compound is called as salicylaldehyde. Okay. In the reactions of phenols we have studied, right? Salicylic acid and salicylaldehyde in Kolb's reaction, Riemann-Riemann reaction. So that compound it is. CHO and OH, if they are attached at the ortho position, it is called as salicylaldehyde. So these are some of the very few examples I have taken for the aldehydes. Okay, if only one carbon is present and if the formula is HCHO, then it is called as formaldehyde. If two carbons are present like this, then it is called as acetaldehyde. If three carbons are there, it is called as propionaldehyde. If four carbons are there, it is called as butyraldehyde. So like that it goes on. Okay. So now let's jump into the IUPAC name of the aldehydes. So in IUPAC nomenclature, you all know we have to follow a suffix, right? So what for aldehyde, what is the suffix? Can anyone tell me the suffix for an aldehyde? For alcohol, the suffix which we have used is OL, right? For aldehydes, what is the suffix used? Very good, Rohit. Yeah, exactly correct, Bharat. It is AL. Okay, so the suffix that we have to use is called as is AL. Yeah, AL is the suffix. Now let me take the same compound. So CH3CHO is the first compound that I have taken in the previous slide, right? So here I have two carbons. So it is ethane, and in that ethane, the E has to be replaced by AL. No, this is not methanol, Harish. Yeah, this is ethanol. So two carbons are there, right? You have to consider the carbonyl carbon also. Okay, you have to consider the C double bond O carbon also. You should not consider only the carbon which is present in alkyl group. Okay, so we have two carbons in this compound. So it is called as ethanol. This is called as ethanol. Okay, so now I will take one different compound. This is the compound. And this compound has double bond as well as carbon-oxygen double bond. Carbon-carbon double bond, carbon-oxygen double bond. And how many carbons are there? 5 carbons. Can anyone try the name for this compound? Can anyone try the name for this compound? Can anyone give a try for this? Students, 5 carbons are there. So what is the root word? If 5 carbons are there, pent-2-ene 1-al. Yeah, very good, Rohit. So since 5 carbons are there, we have to use the root word as pent. Okay. And we have carbon-carbon double bond at the second position. Okay. So carbon-oxygen bond will take number 1. Okay. And the carbon which is attached to it, this carbon is number 2 and this is number 3. Okay. So there is a double bond between carbon number 2 and carbon number 3. So we have to take the lowest number, right? So it is pent-2-ene, and in the first carbon, first position, we have aldehyde. CHO is the aldehyde. Okay. So it is pent-2-ene al. You can say it as pent-2-ene 1-al, or you can leave it like this. Okay. Pent-2-ene al. Okay. This is the name. And let me take the salicylaldehyde. What is the IUPAC name of salicylaldehyde? Can you guess the IUPAC name? Can you guess the IUPAC name? There are 2 substituents. One is aldehyde and the other one is alcohol. Okay. So you all know the preference, right? So in class 11, you would have studied priority list. Aldehyde will take the first place. If you compare aldehyde and alcohol, aldehyde will take the first place, and OH is the alcohol. And since it is taking the second priority, it should be named as hydro. It is named as hydroxy, right? It is named as hydroxy. So present at the second position to this aldehyde. So it is called as 2-hydroxy. 2-hydroxy. 2-hydroxy benzaldehyde. Clear? Yeah, exactly correct, students. And now let's go for one more example. So in this example, we have 3 groups attached to the phenyl group. Okay. And we all know that aldehyde should take the first preference, because on the other side we have alcohol, and the third one is OCH3. OCH3 is the alkoxy part. Okay, like an alkyl. So alkyl, alkoxy, all these will take the second priority only. So you have to start with aldehyde. Okay. So if you number this carbon as 1, this as 2, this 3, and this will take number 4. Okay. So now, how will you name this? I have given you the position, and you all know the name also. OH is called as hydroxy, and OCH3 is called as methoxy. Okay, hydroxy, methoxy. So which one will come first in the name? Hydroxy or methoxy? There we have to use the alphabetical order listing, right? H or M. We all know that H comes first in the alphabet. So the name should be 4-hydroxy. Yeah, 4-hydroxy 3-methoxy benzaldehyde. 4-hydroxy 3-methoxy benzaldehyde. Very good. Very good. Okay. So this is how you have to name it. If you practice with more number of examples, this will be very easy for you. Okay. Don't feel it difficult. Got it? So practice with more number of compounds which is given in the book and in your workbooks. So it will be very easy for you. Okay. You should know the rules. That's all. Rule number 1 is for aldehyde, we have to use the suffix al. Got it? And you should know the priority order. Mostly aldehyde will have the first preference compared to alcohol, alkoxy, and the other compounds, ketones, etc. Now let's go for one more last compound for aldehyde. And can anyone guess the name of this compound? We have a 6-carbon ring attached to CHO. Can anyone guess the name of this compound? Can anyone guess the name of this compound? Yes or no? Cyclohexanal. No, it is not correct. It is wrong. Cyclohexane benzaldehyde. Harish, what is this? We are not having any aromatic system here. We did not have any double bonds, right? Yeah. No issues, no issues. Try for it. So this compound will come under the special case. Special case means we will have an aliphatic ring only. Aliphatic means we will not have any double bonds inside the ring. Those compounds are aliphatic, right? And if aliphatic ring is there and if CHO is bonded with the aliphatic ring, then these compounds will come under the special case category. Okay. Yeah. Very good. So in that case, what you have to do, you have to use a name called carbaldehyde. You have to use a special name called carbaldehyde. So since we have a 6-carbon containing cyclohexane ring here, the name of this compound is cyclohexane carbaldehyde. Cyclohexane carbaldehyde. Okay. So if you're having a 5-membered ring attached to CHO, then it is called as cyclopentane carbaldehyde. Okay, it is not cyclohexanal or cyclopentanal. You have to use the name carbaldehyde. Okay, if CHO is attached to the ring, which is not aromatic in nature, then use the word carbaldehyde. Is it clear for all of you? So these are some of the cases of aldehydes. Do you have any doubts in IUPAC and common names of aldehydes? Shall we go for the common names of ketones? Yes? Okay. So let's go for the common names of ketones. What are ketones? What is the functional group? R, C double bond O, R. Okay. So the first compound that I'm going to take is CH3, CO, CH3. So both the R groups are CH3 here. Okay. So if both are CH3, then the name of this compound is acetone. The name of this compound is acetone. Yeah. Harish, we are in the common names. Okay, the common name will be acetone. Clear? And also, the name of this compound is not ethanol. IUPAC name is not ethanol. Okay. So this is acetone. So now I will take one where we have studied now. In the introduction part, I have shown you, in acetone is present in which compound? In the nail polish remover. Okay, in solvent remover, we have seen this acetone. And the second compound is C double bond O attached to one phenyl ring and one methyl. So what is the name of this compound? If one phenyl ring and one methyl group is attached, then it is called as acetophenone. It is called as acetophenone. Okay. So if both the groups are phenyl, if both the groups are phenyl like this, then it is called as benzophenone. Benzophenone. Okay. Acetone, acetophenone, and benzophenone. Clear? So don't get confused with acetophenone and benzophenone. You should be clear. Okay. Both are aromatic ring, then it is benzophenone. One aromatic and one CH3 means it is acetophenone. Okay. Now let's go for the IUPAC naming. So in IUPAC system, the suffix that you have to use for ketone is ONE. Suffix we have to use is ONE. Okay. So let me take the same compound, the first compound. How many carbons we have here? How many carbons we do have? We have 2 carbons or 3 carbons? Yeah, we have 3 carbons. So what could be the IUPAC name? The word is propane, right? So in that propane, you have to need. So the name will be propanone. The name will be propanone. Very good. Yeah, it is propanone. Clear? So I will take one more compound. So here I have how many carbons? Don't look into the phenyl ring. Okay. Don't look into the phenyl ring. Apart from the phenyl ring, how many carbons we have? How many carbons we have? In this part, how many we have? 3. Okay. There are 3 carbons. And the C double bond O is attached to the phenyl ring. Okay, C double bond O is attached to the phenyl ring. If 3 carbons are attached in this unsymmetrical manner, then you have to start numbering. Okay, the C double bond O carbon should take number 1. Okay, the C double bond O carbon, this carbon should take number 1, and this is 2, and this is 3. Now to the first carbon, the phenyl ring. This ring is called as phenyl ring, right? This is not benzene, this is phenyl. Okay, C6H5 is called as phenyl. So it is attached to carbon number 1. So the name of this compound is 1-phenyl. And since we have 3 carbons, it is propan 1-one. You can call it as 1-propanone. 1-phenyl propanone, 1-phenyl propan 1-one. Both are correct. You can write that one or you can leave it. Okay. 1-phenyl. Can you all able to understand? Can you all able to understand? So if more than 2 carbons are attached in the unsymmetrical manner like this, go for numbering. And while numbering, the C double bond O carbon should get the first preference. That is, the ketone carbon should get the first preference. So is it clear? Shall we go for the next compound? Say yes or no, students. I'm audible, right? Yeah. Okay. Yeah. Thank you. Thank you. So let's go for the next. How will you name this? We have a cyclopentane ring attached to C double bond O, and it is having CH3 group also. So how to name this? So if more than 1 substituents are there, you have to start numbering, right? So while numbering, the C double bond O carbon should get number 1, and here 2, and here 3. Okay, 1, 2, 3. So in the third carbon, in the third position, methyl group is attached. In the third position, methyl, CH3 is called as methyl, right? The methyl group is attached. So the name of this compound is 3-methyl cyclopentanone. Exactly correct. Parveen from JNV Guntur, right? Yeah, exactly correct. It is 3-methyl cyclopentanone. Very good, JNV. JNV Cock, very good. Sunanda Kumari, you have left the number, I think. We have to mention the number of the alkyl group to which it is attached to the ring, right? So it is 3-methyl cyclopentanone. Okay. Yeah. Now one big compound I'm going to give you guys. So try the name of this compound. Can anyone try the name? It's very easy. So just give it a try. We will discuss. I will give you 30 seconds to solve this. Fast. What is the name of this compound? Somebody has got, Rukmini has got the answer. 4-methyl 5-bromo octanone. Partially correct, but not exactly. Rukmini, try. Refine your answer again and give the correct answer. 5-bromo 4-methyl octan 2-one. Very good. Very good. The student from JNB, okay, have got the correct answer. Yeah, it is exactly correct. It is 5-bromo, 4-methyl, octane 2. So you have to start numbering from this. So this is the long chain, right? So this is the long chain. So you have to start numbering. Yeah, Kokrajar. When we Kokrajar, and what is the name of you? You may know your name. Only one is watching or the whole class? Oh, it is Bishan. You have joined your school name today? Okay. I know Bishan Basmati. I know. Very good, Bishan. It is correct. So we have to go from left, right to left, right? H3 has to take number 1 and this is 2, 3, 4, 5, 6, 7, 8. So to the fourth carbon, we have bromine. So we have two substituents. One is methyl and the other one is bromo. One is methyl and the other one is bromo. Okay. So according to the alphabetical order, bromine comes first. According to the alphabetical listing, bromine comes first. Right. So what we have to do? B comes first. So it is 5-bromo, 4-methyl, octane. And to the second carbon, we have this ketone group. So it is octane 2-one. 5-bromo, 4-methyl, octane 2-one. So do any of you have any doubts in finding out the name of this compound? Is there any confusion? Is there any confusion? Is it clear to all of you? Okay. So this is all about the common names and IUPAC aldehydes and ketones. Okay. So now let's topic which is called as preparation of aldehydes. Preparation of aldehydes. So let's go for the first preparation. The first preparation of aldehyde is from acyl chlorides. The first method of preparation is from acyl chloride. Acyl chloride formula is RCOCl. Acyl chloride formula is called as RCOCl. And if you treat this acyl chloride, RCOCl, with hydrogen in presence of palladium barium sulfate, you will get aldehyde and HCl as the product. Okay. So we are using hydrogen in presence of a catalyst called palladium barium sulfate. So this particular palladium barium sulfate hydrogen catalyst is called as Rosenmann's catalyst. Okay. So the reaction is named after the scientist Rosenmann. The name of the reaction is Rosenmann's reaction. Okay. So very easy reaction. The COCl part will be converted to CHO. The COCl part will be converted to CHO. So within a single step, you can get the answer. But you should know the containing compound is a Rosenmann's reagent. All right. So let me give you one example. Let me give you an example. CH2COCl in presence of what will be the product? The name of the reactant is called as propanoyl chloride because we have 3 carbons, right? We have 3 carbons, 1, 2, 3. So it is called as propanoyl chloride. So what is the name of the product that you will get from this reaction? Can anyone give a try? You can give me the name of the product or you can give me the formula of the product. Give any one. What could be the name or the formula for the product that you will get from this reaction? Very good. Very good, Sunanda Kumari. The answer is correct. The answer is correct. Yeah. Yes, Rohit. It is CH3, CH2, CHO. We have 3 carbons. So it is called as propanol. So from propanoyl chloride, we will get propanol. The COCl part will be converted to CHO. Okay. So let me give you one more compound. An aromatic compound. C6H5COCl. In presence of hydrogen, palladium, barium sulfate will give a product X. What is X? The name of the reactant is benzoyl chloride. So what will you get from this benzoyl chloride on reaction with Rosenmann's reagent? Yes, the answer is benzaldehyde. Very good. The COCl part will be converted to CHO. So it leads to the formation of, yeah, benzaldehyde and HCl. Okay, benzaldehyde. So the reaction is clear, right? So very easy preparation among all the preparation of aldehydes. Rosenmann's reaction. So keep the reagents. Hydrogen in presence of palladium, barium sulfate is the Rosenmann's reagent. And that reagent will convert COCl to CHO. So this is what you have to learn. You don't have to memorize all the reactions which is there in the list. Okay. So just study the reagent and the conversion. That is enough. Okay. So whatever might be the reactant or whatever might be the starting material given to you in the exam paper, you can close your eyes and give your answer. Okay, you don't have to recall the reactions that you have memorized. Okay, because the mechanism you know, right? COCl will be converted to CHO on treating with this particular reagent. So you can close your eyes and give your answer. Okay, so you won't make any mistakes if you study like this. If you start memorizing all the reactions, all the preparations, all the chemical reactions given in all the organic chemistry lesson, you will end up with the confusion. Okay, so don't memorize, learn the reagent and the action of that reagent in a reaction. Means how it is converting a particular compound to another compound. Okay, so learn in that way. Conceptual understanding is very important. Memorizing will not give you any good marks. Okay, because if you memorize these reactions, if some other reactant is given to you, then you will be, what to say, you will be thinking, okay, whether it is correct or the answer which you have written is correct or wrong, kind of confusion. You'll not be confident in the answer. Okay, so better learn the conversion and the reagent. Don't memorize all the reactions. All right. So let me go for the second preparation. From nitriles and esters. The name of the reaction is Stephen's reaction. Stephen's means we should know, right? We should know the Stephen's reagent. So since the title says that we are going to prepare the aldehyde from nitrile and ester, let me go for nitrile first and then we can prepare the aldehyde from ester. So let us start with the nitrile. What is the formula for nitrile? Can anyone give me the general formula for nitrile? Can anyone give me the general formula for nitrile? We have studied, right? We have studied in the in class 11, in the previous lesson. Very good. RCN is called as nitrile. So RCN on treatment with Stephen's reagent will give aldehyde. Okay. RCN is called as aldehyde. Sorry, nitrile and treatment with Stephen's reagent. You see the reagent? SnCl2 with HCl. What is Sn? It is a p block element and it is called as tin. Okay, tin. So SnCl2 is tin chloride. Yeah, very good. Tin chloride with HCl and on acid hydrolysis. Acid hydrolysis means H3O plus reaction. No, Sunanda Kumar, it is not thionyl chloride. Thio means sulfur. Okay, this is tin chloride. So tin chloride with HCl and in presence of H3O plus will give the aldehyde. Okay, so let me explain you in a stepwise manner. First, let us take the nitrile. RC, the triple bond N is the complete formula. Okay, and first it has to be treated with SnCl2 and HCl. And this reagent, this Stephen's reagent is a reducing agent. So what is meant by reduction? Addition of hydrogen is called as reduction. So what you do? So we have 3 bonds. We have a triple bond between carbon and nitrogen, right? So break one of the bond, addition of hydrogen. Break bond and another hydrogen to nitrogen. Add one hydrogen to carbon and another hydrogen to nitrogen. So you will end up with the compound like this. Okay, so in 3 bonds, I have broke one bond and I have added hydrogen to both the atoms. And carbon double bond nitrogen containing compound it is. Carbon double bond nitrogen containing compound is called as imine. It is called as imine. Okay. Then in the next step, we have to use H3O plus, right? So if you hydrolyze this, you will get aldehyde. Okay, the NH group will be converted to O. So you will get R, CHO and NH4Cl, all these are the byproducts. So the main product we have this reaction is, all of you, can you all able to understand? So what is the conversion? CN on treatment with Stefan's reagent is forming CH double bond NH, and after that with hydrolysis it is forming CHO. CN is getting converted to CHO at the end. Okay. You may ask me, ma'am, why do we need to do such conversions with these 2 steps and all? Because in some questions, they will ask you to find out the intermediate that is formed. Okay. So imine is the intermediate formed in this reaction, right? So to write the intermediate, you need to know the complete step. Okay. For some reactions. So you should study all the intermediates involved in all the reactions given in the book. So that's why I am teaching. Otherwise, I can say that CN will be converted to CHO if you treat it with these 2 reagents. Like, so you should not study in that manner. The reactions which are involved with the intermediate formation, study everything. Okay, given in those things. Now I'll go ahead with one more reagent. Okay, I'll go with one more reagent. That is, we can also use diol hydrogen instead of SnCl2 and HCl as a reducing agent. What is meant by diol H? Diol H is diisobutyl aluminium hydride. Diisobutyl aluminium hydride. So instead of this SnCl2, I'm going to use this. And it will also do the same job. CN CHO. Okay, you see here. Isobutyl aluminium hydride. Okay, H is called as hydride. So this reagent will also convert CN to CHO. Okay. Now let me come to the ester. So far we have studied about nitrile. Now let us start with the ester. What is the formula for ester? What is the formula for ester? Do you guys know the general formula for ester? No. ROR is ether. Ether is different from ester, right? ROR is ether. Very good, Parvin. RCOOR is called as ester. So esters are also reduced to aldehydes with diol H. Let me take RCOOR, which is an ester, and I will try to treat it with this diol H. And it is converting the COOR group to CHO. It is converting COOR group to CHO. Okay. So what is the role of this diol H? CN to CHO, COOR to CHO. Okay. So now we will study 2 examples based on these 2 reactions. Okay. And you are going to give me the product. Product will be there. Yeah. Listen. Benzonitrile. C6H5CN is the benzonitrile. And the CN group is getting converted to CHO on treatment with Stefan's reagent. And here, this is an ester. Methyl propionate is an ester. COOR. The COOR is getting converted to CHO on treatment with dibal H. Okay. These are some of the examples. Any doubt from this? Any doubt from the first two preparation of aldehydes? Shall we go for the next? Shall we go for the third preparation? So the first is Rosenmann's reagent. Second is Stefan's reagent. Third is dibal H. Any doubt from these three reactions, students? We go for the third main category to prepare the aldehydes. Okay. So third is from alcohols. Third is from alcohols. So mainly primary alcohols. Primary alcohols on treatment with mild oxidizing agents like PCC gives aldehyde. The full form of PCC is pyridinium chlorochromate. Pyridinium chlorochromate. Okay. So now primary alcohols with PCC is going to give aldehyde. Can you give me the formula for primary alcohol? We have studied, right, in the previous lesson about alcohols. Can anyone give me the formula, general formula for primary alcohol? You don't have to give me the example. Just give me the general formula. Is it ROH? ROH is the general formula for alcohol. I am asking for primary alcohol. What is the general formula for primary alcohol? H, no. ROH, R-OH. What is the difference between the two? Huh? What is the general formula for primary alcohol? No, nitrogen will not come. Why nitrogen is coming here? No, Parveen. So this shows that you guys are not studying at all. Am I right? So we have learned alcohols, phenols, and ethers. In the entire lesson, we have spoke about this alcohol. And I have talked to you about primary alcohol, secondary alcohol, tertiary alcohol. But even now, you guys are not giving me the general formula for primary alcohol. Why you guys are like this? At last, one person gave me the correct answer. I'm happy about that person. Rukmini, your answer is correct. Your answer is correct. The formula for primary alcohol is RCH2OH. RCH2OH. On treatment with PCC, it is giving RCHO. So guys, you have to go and okay. You have to go and so please don't be like this. Still we have time. Please go and revise all the topics and the lessons that we have discussed so far. Clear? So coming to the lesson, primary alcohol will give aldehyde and the example that I'm going to take is CH3CH2OH. CH3CH2OH is an example for primary alcohol and the name of this alcohol is ethanol. If I treat it with PCC, it will give ethanol. It will give ethanol because we have 2 carbon, right, in the alcohol. So the 2 carbon containing alcohol will give 2 carbon containing aldehyde. Okay. So ethanol will give ethanol. Propanol will give propanol. Butanol will give butanol. So like that it goes on. So PCC will stop up to aldehyde. It will not oxidize further. Okay. So that's why it is called as mild oxidizing agent. So alcohol on oxidation will give aldehyde first. Primary alcohol will give aldehyde. Secondary alcohol will give ketone. Secondary alcohol will give ketone. So that ketone preparation we will discuss later. Now we are preparing the aldehydes, right? So let me confine to this primary alcohol. So this is the third method of preparation of aldehyde. That is from okay. It is from hydrocarbons. Fourth method of preparation is from hydrocarbon. The first is from acyl halide. Second is from nitrile and ester. Third is from alcohol. And the fourth is from hydrocarbon. Okay. So under this hydrocarbon topic, we have subdivisions. The first subdivision is called as reductive ozonolysis of alkenes. Reductive ozonolysis of alkenes. So what we have here? We have an alkene. Alkene means carbon double bond carbon system. It is treated with ozone. What is ozone? O3. This reductive ozonolysis, we have to use a reducing agent. So all the metals are reducing agents, right? So zinc with H2 is the reducing agent here. So this leads to the formation of aldehyde. 2 moles of aldehyde we are getting from this. How does it obtain? So the mechanism is given. It is very easy. So first write the reactant, okay, and treat it with ozone first. In ozone we have 3 oxygen. So break the double bond. Break the 2 bonds in this double bond and write a 5-membered ring like this. Write the 5-membered ring like this. Then you have to break the bonds given in this manner. Okay, we are getting a ozonoid, and if you treat this with zinc in presence of water, by breaking these bonds, you will get aldehydes. So here we have RCHO, and this side we have RCHO. So we get 2 moles of aldehyde and zinc oxide will come out. Okay, so you can get the answer by trying this mechanism, or you can use this trick. This is a trick. Break carbon-carbon double bond and add oxygen on both the carbons. So what you can do, you can break this carbon-carbon double bond and you can add oxygen to both the carbons. What will you get? If you add oxygen and break this bond, you will get RCHO and here RCHO, right? So if you want to find out the product easily, break the double bond, add oxygen to both the carbon. Okay. So in the examination, if they are asking you to find out the intermediate, then you should know how to get the intermediate also. Okay. You have to break the carbon-carbon double bond and you have to add O3 in the 5-membered ring formation manner. Clear? Clear? I will give you the examples. Listen. So first, 2-butene. So I bond and adding oxygen to both the carbon. So what will we get? CH3CHO and here CH3CHO. So 2 moles of ethanol is coming out. Okay, and here you see, if I break this bond and add 1 oxygen here, I will get oxygen in one side. I mean CH3CH2CHO and here also CH3CHO. So propanol and ethanol we will use. Okay, it is a solvent, Rohit. Rohit, it is a solvent. So in many reactions we use, in acid hydrolysis also we are using, right? H plus in presence of H2O. So in the same way, Zn in presence of H2O. Okay. So we have a big mechanism. So in one of the steps, the what solvent here. This is acting as a solvent. Clear? Yeah. So this is the first method of preparation of aldehyde from hydrocarbon. From hydrogen and carbon containing compounds we are preparing, right? So this is the reductive ozonolysis part of alkene. Now coming to the second preparation from hydrocarbon, it is Itard reaction. Itard is the name of the scientist and this reaction is very, very important reaction. Okay. So here also we are going to take a hydrocarbon, but it is an aromatic hydrocarbon. So the compound is toluene. I am taking toluene and we have to use Itard reagent, right? So the reagent is chromine chloride, CrO2Cl2. CrO2Cl2 is called as chromine chloride. Carbon disulfide is a solvent. Carbon disulfide and H3O plus are the other reagents. So this particular etad reagent will convert CH3 group to CHO group. So we get an aromatic aldehyde from this aromatic hydrocarbon. Okay. CH3 group is getting converted to CHO. Let me show you the mechanism also. Toluene with chromyl. In toluene, we have CH3 and in that CH3, we have 3 carbon hydrogen bond. How many carbon hydrogen? 3 carbon hydrogen bond. So what you have to do, you have to take 2 carbon hydrogen bond and insert this CrO to Cl2. So keep 1 carbon hydrogen and between the other 2 carbon hydrogen bond, you have to insert CrO2 Cl2. CrO2 Cl2 and this is the hydrogen which has been attached to this carbon. So what I am telling? Between 2 carbon hydrogen, you insert the CrO2 Cl2 group. Okay, so we will get 2 groups like this. And this complex is called as chromium complex. Here. Okay. So, read this structure is in one of the previous year exam, competitive examination, they have asked this. Okay, they have asked to find out the intermediate complex formed in the reaction. So you should know it is very easy. Don't get scared by looking into the formula here. In the book, it is given in this way. But the very simplest way to keep this in mind is in 3 CH bond, take 2 CH bond and insert the CrO2 Cl2. Insert. I am telling insert. Okay. So in the next step, you have to do the acid hydrolysis thing. If you treat it with H3O plus, the entire part, so this entire part will be converted to CHO. Okay, the final product you will get from toluene to benzaldehyde. Clear? Action it is. So reagent, the complete reagent, CrO2 Cl2 with CS2 in presence of H3O plus. And that will convert the CH3 group to CHO group. Okay, so this is the second method of preparation. Now coming to the third method of preparation. It is again an easy reaction, but very important, called Gattermann-Koch reaction. 2 scientists. One is Gattermann and the other one is Koch. So these 2 people directly converted the benzene to benzaldehyde. They directly got this aromatic benzaldehyde from benzene itself using this reagent. Reagent looks little bit bigger, no? But it is very easy. You can memorize the reagents. What are the reagents? Carbon monoxide, CO. Carbon monoxide, it is not cobalt metal, okay? So both carbon and oxygen are given in the capital letters, no? So it is carbon monoxide with HCl in presence of anhydrous AlCl3 or CuCl. Okay, anhydrous AlCl3 or CuCl. So this is the Gattermann-Koch reagent and this reagent will convert benzene to benzaldehyde. Okay. There is no steps involved. You can get this aldehyde directly from benzene. Clear? Shall we go for the... Let us complete the preparation of aldehyde from hydrocarbons. Okay. Let us complete this particular category alone and then we will wind up the class. Any doubt from Gattermann-Koch for anyone? Shall we go for the next reaction? Yes. Any doubt for anyone? Am I audible? You guys become silent all of a sudden. Okay. Okay, thank you, Vishan. So coming to the fourth preparation from hydrocarbon, it is side chain chlorination hydrolysis. So again, you have to take an aromatic hydrocarbon. And we are going to do chlorination, right? So we have to use chlorine, Cl2. So side chain chlorination means you have to do this reaction in presence of sunlight. So sunlight has this H nu, right? H nu. So H nu amount of energy will come UV radiation from sunlight. So in presence of this H nu and Cl2, the three hydrogens which are present in the attached to the alkyl group, among those three hydrogen, two hydrogen will be replaced by two chlorine. So what will be the intermediate formed? We have a ring and two hydrogen will be replaced by two chlorine. C6H5, CHCl2 we will get. And this compound is called as benzyl chloride. This is called as benzyl chloride. And this on treatment with H3O plus will give the benzaldehyde. So the intermediate formed is very important. Okay, the formula is very important, CHCl2. Because they will confuse with the CH2Cl, CCl3. So that kind of options will be given. In that case, you should not get confused, okay? So two hydrogen will be replaced by two chlorine and the name of the compound is benzyl chloride. Okay, and this method is the commercial method for the preparation of benzaldehyde. This method is the commercial method for preparation of benzaldehyde. Okay, is it clear to all of you? So these are the four reactions which comes under the hydrocarbon category. Okay. So what was the first reaction? From acyl chloride, Rosenmans. Second from nitrile and ester, there it is Stephens. And in the third preparation, what we have used? In the third preparation, do you guys remember the third method of preparation of aldehyde? What was the third method of preparation? Yeah, alcohol. From alcohol, primary alcohol with PCC gave aldehyde. And the fourth method of preparation is, yeah, hydrocarbon. From hydrocarbon. So from hydrocarbon, under hydrocarbon, we have studied four reactions. Okay, so 1, 2, 3, 4. And under 4, there were 4 subcategory. Okay, so please go through all the preparation of aldehydes that we have discussed today. And in the next session, that is tomorrow, we will solve some previous year question of the topics of the reactions which we have studied today, and then we will move on to the next topics. All right. Here, H3O plus is used to hydrolyze H plus H2O. H plus H2O. The role of this H plus H2O or H3O plus is the converting all the groups to aldehydes, whether it is CHCl2 or the big compound which we have studied in ITAD reaction. Okay. So whatever might be the groups attached to the ring, the H3O plus will convert the entire group to aldehyde, CHO. Is it clear? Is it clear for all of, for Harish? Yeah. Okay, students, do you have any doubt in today's session? Okay. So I have launched a poll. You guys can give your answers over there and then you can leave the class. Okay, thank you so much for attending the today's class. Please revise before you come for the next class. Okay. Yeah. Yeah, Harish, it is only for aromatic ring. It is only for aromatic ring. Here in case of aromatic ring, it is doing.